Alright, hey y'all, it's Mr. Kyle, Myers Mathematics, and let's just jump into it. I went ahead and worked this one out ahead of time because I was looking at it and I was like, this one is a little crazy. I was trying to think of using methods that I've used on the past couple problems, and I was like, maybe it's 2, but just using a t-chart, looking at the graph, looking at what the ln function does as it goes to infinity. All that stuff was not adding up as well. And then I changed it and changed the base, and I was still like, until I used L'Hopital's rule. Good old L'Hopital's rule. And then confirmed that the limit of this was in fact 2. So if you're looking for the answer, it's 2. But as far as the reason why, let me get into that real quick, because you might come up with a strategy and then that strategy doesn't pan out as well as you might have thought it would in the first place. Whenever we have the same base in the numerator and in the denominator, you might think you want to try to condense. That was kind of my first reaction, and then I was like, oh, no, you can't condense unless it's a log plus or minus another log, and then you would be able to condense those. So we can't condense them, but you can do, I forget what the official name is for it, but it's like a change of base formula. If the log has the same base in the numerator and the denominator, you can write it as one log, with the logarithm number in the denominator being the base, and then the logarithm number in the numerator just kind of stays the logarithm number. So we can rewrite a sub n, or the sequence a, with n as the variable. We can rewrite it as log base 2n of n squared. But it's like, okay, well, what do we do with that? Like, what does that even look like? For the first couple of values, it's not that bad. I think most of your values are going to be irrational numbers, but it looks like 1 is 0, 2 is 1. Number 4, and when n is 4, you have 1.3 repeating, so that's a rational number. The other ones, I'm not really sure if they were rational or irrational. It didn't look like there was a repeat in the decimal, but I could be wrong on that. Anyways, they're crazy decimals, but you do get closer to 2 as you go to bigger and bigger numbers. So as you can see here, I tried to type out some numbers. I used Desmos for that, but you could also use a scientific calculator. Hopefully your teacher's at least letting you use a scientific calculator. Then what I did was I said, okay, maybe there's a way to pick apart the bases. And I think there probably still is, but I was like, I don't know if that's the best way to do it. So that's what I was doing off to the side over here. I was like, okay, well, we know log base 2 of 64 is 6. Log base 2 times 2 is 6 of 64. Would be log base 4 of 64, which is 3. So I was like, okay, like, is there a pattern here? What kind of pattern could I try to find? Because I was trying to remember what there's like a way to split up the base of a logarithm, and I was trying to remember what that was. That's what you have off to the bottom right-hand side over there. But then I kind of got stuck with the log base 2 of 36, log base 3 of 36, and then log base 2 times 3 of 36, which is 2. So I'm not really sure what that was, because I'm pretty sure 5.1 and 3.2, that shouldn't make 2. But yeah, so that's what I was doing over there. But then L'Hopital's rule works out really well, because if we're plugging in infinity, or if we're looking at what happens when you are taking the limit as it goes to infinity, the top and the bottom would both be infinite. So it's indeterminate form, which means we can use L'Hopital's rule. So then we take the derivative, and the derivative of ln is 1 over. So it's 1 over n squared times the derivative of the inside, chain rule. So 1 over n squared times the derivative of n squared, which is 2n. All of that over, taking the derivative of ln again, so it's 1 over, so it's 1 over 2n times 2. And then that simplifies all the way to 2. You don't even have to try to plug in infinity again. It just simplifies to 2. So that ends up being the answer. And they didn't say what method you had to use, so you can use whatever method you want. And I think L'Hopital's rule would probably be the best way to do this one. So the limit of the sequence, aka the limit as a sub n goes to infinity, the limit as n goes to infinity of a sub n, would be 2. So it converges, and it converges to 2. All right, well, that's about it. Hopefully that's been helpful. Go check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF guide on my website, myershmathematics.com. Link in the description below, and I'll catch you all in the next one. Blessings, y'all.